Recall that when we looked at percentiles, we talked about the fact that there are three very important and special percentiles, namely the 25th percentile, this green line right here, the 50th percentile, which is this blue line right here, and the 75th percentile, which is this purple line right here. Also remember that they can be closer together, farther apart, right? What matters is that there's a percent of data, well, 25% of the data is less than the 25th percentile, 50% of the data is less than the 50th percentile, and 75% of the data is less than the 75th percentile. That's what matters. So it's not necessarily about how close or far apart they are, it's about the percentage of data that are less than those values. So we want to talk about those three values in a little bit more depth because they're actually the most important ones we work with percentile wise, and therefore we're going to do a lot more with them than we would with other percentiles. So they're so special, they get their own name. They're called quartiles. So the quartiles are the three values that divide an ordered data set, order meaning it goes from low to high, so it's been put in order, into four equal parts. There's the median, which is the 50th percentile. That's that blue line in the center. So since it's the 50th percentile, it's also the second quartile, or Q2. So P50, capital P, lower subscript 50, or capital Q for quartile, little lower subscript 2. Then the first quartile, which is this green line right here, is the 25th percentile. And the third quartile, which is this purple line over here, is the 75th percentile. Now you'll notice that when I drew this, and we'll talk about the drawing that I made here in just a second, but when I drew this, I made it so that they're not equally apart, right? There's no equal widths here. I mean, there might be, but it doesn't have to be. It's not a guarantee. The quartiles don't guarantee equal width. What they guarantee is that each of the sections from the minimum, that's the smallest number in your data set, up to Q1 will have 25% of the data. And then from Q1 to Q2, there'll be 25% of the data. From Q2 to Q3 will be 25% of the data. And from Q3 to the max will be 25% of the data. So it's not that the widths are the same, right? They can be close together, they could be far apart, right? The Q1 could be all the way over here, practically on top of the Q2. Technically, actually could be on top of the Q2, but that's a little weird, right? It could be very close to the min, it could be anywhere in there. But what happens is no matter where it gets moved to, 25% of the data points are in each of those sections. So let's say you had, I don't know, an exam with 100 students taking it. Well, then 25 students are in each of these four zones. If you had 200 students taking it, it'd be 50 students in each of the zones. That's what's key about a quartile. Right? So it's not that the sections are equal width. Matter of fact, the fact that they're not can show you something very interesting about your data set, namely if it's skewed or not. Right? Some can be wider than others, but it does contain 25% in each section, right? So I realized my English there was not too great. So they are equal in containing 25% of the data set each. There we go. Leave it. All right, now a couple other things before we move on. This graph that you're looking at, this is not your average graph. This is actually a really important graph. It used to be called a Box-and-Whisker Plot, and it still is in some books, but a lot of the times that's getting dropped to just box plot because it's easier. So it's got a box from Q1 to Q3, and it has whiskers sticking off on the end of it. We'll talk about that a little bit more later on in the more 3-5 section of this. But suffice it to say that it's a really powerful graph because it shows you something very powerful called the 5-number summary. Now the 5-number summary is a really concise way of showing the distribution of a data set. It's actually super powerful, and honestly for a lot of applications it's better than a histogram, it's better than a bar chart. I mean, well, bar charts are for qualitative data, but I mean it's better than a lot of the graphs that we work with because it shows numbers that are not affected by outliers. These 5 numbers that you're looking at, well, the min and the max are affected because they're generally where the outliers are. But the 3 quartiles in the middle are resistant to outliers. They're resistant to skewing. And that's really nice to know. So the 5-number summary is a very powerful measure of the distribution of your data set. How spread out is it? What's its range? And what's its center? Now the center is the median line. So because remember, center is another word for average in math in statistics class. And the median is a really good measure. If you don't know if your data set's skewed or not, go with the median, right? The median measures the center nice and cleanly. Then it tells you your range as well, because it gives you max to min. So you see where your lowest values and highest values are. And again, if you have any outliers, they're going to tend to be on those edges. Then it also gives you a measure of spread. Now we haven't learned this yet, so bear with me here, but the IQR is the interquartile range. In other words, what's the width of the box? From Q1 to Q3, how wide is it? Because if your data set has a really wide box, that means that the interior spread, the spread of the middle part of your data set, is really wide. If you have a really narrow box, it means that your data points in the center are really narrow, really close together, so you don't have a lot of spread. So the width of the box is a visual of how widespread your data is. Neat, huh? So it's a very, very powerful tool that was invented in the 1900s, and it's gained in popularity more and more. So a very, very powerful graph and a very, very powerful number summary. And to be honest with you, when I give out exams in a math class, I don't give students the mean and the standard deviation. This is what I give students. I give students the min, the Q1, the median, the Q3, and the max. Having those 5 numbers tells you where your position is for you. If you know you're below the Q1 on an exam, that's not good, right? You know you need to study more. If you know you're between Q3 and the max, you know you did pretty well. You're in the top 25% of test takers, and so on. Right? You know where the median is, you know above and below, that kind of thing. So the 5-number summary is a very powerful measurement of spread. It measures position and it measures the center. It's just a very, very powerful way of summarizing a data set quickly. So it'll be important for us to know how to find these values. So we are going to find them. So we're going to find them by hand and with a calculator. Okay, so let's make a note of a few things here. So I have a data set. This is a sample of Math 133 Exam 3 scores from winter 2014. Yes, it is actual exam scores, however, it is just a sample. All right, so we want to find the 5-number summary, and I'm going to add the caveat by hand and with calculator. Okay. Well, by hand, it's really easy when your data set's in order like this and it's not very large. So the minimum's kind of obvious, it's 54. And by the same token, the maximum's kind of obvious, it's 93. That was done. We wish all of our exam questions would be so easy. All right, now the median is also pretty easy to spot because it's highlighted in blue because I've already done this problem before and twice, as a matter of fact, and my computer ate the video twice. So I'm hoping the 3rd time will be the charm. It happens. All right, so 84 is the median, no problem. Half the data is below, half the data is above. Great. Now, let's look at how many data points are below. When you count how many of these there are, there's 14 of them. So you want the median of those 14 numbers. That will be Q1. So the Q1 is the median of the bottom half of the data, which really means what you're looking for is the mean of 75 and 77. So if you take 75 and 77, oops, wow, that was bad, and you add them up and divide by 2, you'll get the Q1. And if you want to see me do that with a calculator, I mean, I did it in my head, but I also have done it with a calculator. Make sure that you type parentheses when you do it and close that parentheses and then divide by 2. And there you have it. Similarly, Q3 is the median of the top half of the data. So it's the median of 88 and 89. So if I take those 2 values, I'm going to get 88.5. Wonderful. Now, that was doing it by hand, of course. And then the thing about doing it by hand is that you'd have to have the data set in order because it's for an ordered data set. See that ordered data set right there? All right, so what if it wasn't in order? What if it was just a data set you had typed into a calculator? Well, we can do that too. So let me go grab the calculator. I'm going to type in all my data points. So I'm going to go to Stat, I'm going to go to Edit, I'm going to go up and press Clear. And actually, I don't need L2 either. I'm going to clear out both of them just so that it's not there and confusing you. So everything's cleared out, and I'm just going to type in all my data points. So I'm going to pause you. I'll be right back. Okay, they're all typed in. So now if I go to stat and calculate and run one variable stats, which is what we've been doing through this whole, well, almost the whole chapter except for section 3.3. So 3.3 needed the frequency list. However, we're out of 3.3. We're not doing a table of data or weighted data. So we're going to clear out the frequency list and we're going to go down to calculate and press enter. All right, so there's the X bar. Now look down here at the very beginning or very bottom. See the minimum at 54. Q1 was 76. Ding, ding, ding. So if I scroll down with my down arrow, 84, 88.5, 93. And see those bottom 5 numbers? The calculator is giving you the 5-number summary. See? I don't just invent it for my health. The 5-number summary is a common stats technique of ways of looking at data. So it's the last 5 numbers that the one variable stats gives you because it's a super powerful measurement of the spread of your data. And that's how to find it with your calculator.